Okay, you should all have in front of you this worksheet, and you received it in class or you've either printed it off of eClass, but we need to talk about how to classify reactions because there are different types. Okay, so the first type thing you need to ask yourself is there only one reactant? Now remember, um, your reactants are on the left side of the equation and your products are on the right side. And if the answer is yes, that means you have decomposition. Now, if you think about it, it's when a reactant breaks up. And anytime you have decomposition of leaves or decomposition of a body or things like that, it's when you're breaking up. Okay, and so when you're breaking up, that's kind of like divorce, okay? Because chemical equations are all about the relationships between compounds and things like that. And so this is divorce. You have a couple that has now broken apart, and they're in two separate pieces. For example, magnesium and oxygen are happily a couple here, and then they go through a divorce, they break up. This is decomposition. Okay. Now, if you don't have one reactant, but you only have one product, that is called synthesis. Okay, a synthesis reaction. And this is when you have two things that make one thing, which is like marriage. It's when two people get married. Two individual people become one couple. And so these are the reverse of each other. Okay, they're backwards from each other. And so if you don't have just one reactant and one product, okay, we need to think, is oxygen a reactant and water a product? And if the answer is yes, you have combustion. And this is when things go boom. These are our favorite reactions because you add a little bit of spark and you will have a combustion reaction. And so this is when you have a hydrocarbon, okay, which is something that has carbon and hydrogen in it, with oxygen when it's burning to produce water, energy, and most of the time carbon dioxide. And so kind of looks like this a little bit, or for example, this type of reaction, most of the time producing carbon dioxide. And if it's not combustion, we come down to the single displacement and double displacement. And so if you have an element in a compound that have kind of switched place, we call this single displacement. And my little indicator for this is I call this the Homewrecker. Okay, and this is because you have an element that comes in and breaks up this couple, and now B is all by itself, and AC is the new couple. So A is a little hoe that came in and broke up the couple, and they're a little home wrecker. Okay, so for example, magnesium comes in here and steals oxygen away from beryllium, and now beryllium's all sad. Sad beryllium, he's by himself, and magnesium is now a couple. So they've kind of swapped places there. And it was a single displacement because one thing is still single, it's by themselves. Whereas if we have two different compounds, it can be double displacement. And if you've ever seen the movie Wife Swap, where you have a family that has two, uh, the moms or the wives swap places, that's kind of like what this is. For example, here you have oops, A and C are going to swap places. So A and C swap places to produce AD, and oops, this should say CB. Okay, so that's kind of what's produced there. And notice that you had to write this in the particular order that it came in. A and C are at the beginning, so they have to be at the beginning of the new compounds. So they just kind of swap places. So in our example, we have magnesium and beryllium swap places, and now magnesium is with sulfur and beryllium is with oxygen. They've swapped places. So we can use this to help us identify our things. Now, you can remember divorce and marriage and homewrecker and wife swap, but that's only going to be useful if you can also remember the scientific term that it goes with. So I highly recommend writing flashcards or something along those lines to help you practice remembering. So if we want to practice kind of identifying our reactions, if we look here, we have an element by itself with this that swaps places to become with AX. Now, that's the Homewrecker. A is coming in and breaking up BX to steal X away from B. So Homewrecker would be the single replacement. So number 3 is A. If we look at B, we have two things that become one thing, which is like marriage, which is synthesis. And when you synthesize something, you're creating something new. In this case, you're creating a new marriage or new compound between elements A and element X. And if we look at C, we have a compound here and a compound here, and we can see that A and B have kind of swapped places from before. And when you swap places, that's a double replacement or a wife swap. And in letter D, we see that we have water and carbon dioxide as a product, and we have this hydrocarbon here. And that automatically means it's the one that's going to go boom. So number 5 is D. And then if we continue on to letter E, we have AX that's breaking up, okay? And when you're breaking up, you're decomposing. So number 2 is E. And we can practice that with not generic letters, but with actual compounds. If we look at things here, okay, so here we have one reactant that's breaking up into two things. And remember, when we break up, it's going to be decomposition. And if we look at number 7, we have hydrogen and sodium that swap places so that sodium is now with chlorine. And you can rewrite water as HOH to really see how this hydrogen has swapped places. And so that would be a double replacement reaction or a wife swap. And I recommend that you continue to look through the rest of these and balance them and, well, not balance them, but classify them on your own. You will have questions like this on your quiz, your test, and your final exam.